Good morning, students. The next topic we are going to see is about radius of gyration. So, what is the radius of gyration? It is a perpendicular distance from the axis of rotation to an equivalent point mass, which would have same mass as well as same moment of inertia. Okay, so radius of gyration is said to be the distance between the axis of rotation to an equivalent point mass. Suppose consider this to be the axis of rotation and this to be the point mass. Okay, so the distance between these two, okay, axis of rotation and the point mass, which would have the same mass. So which will have the same mass? This axis as well as this point will have the same mass as well as same moment of inertia, and that distance is said to be the radius of gyration. Clear? So the radius of gyration is defined as the perpendicular distance from the axis of rotation to an equivalent point mass. அது ரெண்டுத்துக்கும் எப்படி இருக்கணும்? It should have the same mass as well as same moment of inertia. Clear? Here I is equal to m into k square, where I is the moment of inertia and m is the total mass and k is said to be the radius of gyration. Clear? Now when we consider whether so many objects which have some masses m1, m2, etc. up to mn, and it is of radius r1, r2, etc. up to rn, then the moment of inertia, what is the formula for moment of inertia is I is equal to summation mi into ri square. Instead of this mi and ri, we are going to write with the term, first one is m1 into r1 square, next m2 r2 square plus etc. up to mn rn square. Okay, so this is a general form. And now next is, if we consider all the masses, okay, so this is m1, this is m2, this is m3 and m4. So this is from the axis. What is the formula is, that is the, what is the definition is, from the axis to an equivalent point mass, if we consider any distance, that distance is said to be the radius of gyration. Okay, now the next is, if all the masses are equal, m1 equal to m2, all these masses we are writing as m அப்படின்னு எழுதணும் அப்படின்னா, so m1, m2, m3, mn எல்லாத்துக்குமே m ன்னு எழுதிட்டோம். In this, m is constant, that is a common in all this, so we are taking it out. Remaining is r1 square, r2 square, r3, etc. up to rn square. Okay, now what we are going to do is, in this step, multiply and divide by the term n அப்படின்னு பண்ண போறோம். So n we have multiplied, same way n we have divided. So this term fully is said to be k square, because this is equal to the radius of gyration, and this n into m can be written as capital M. So nm is a total mass and k is said to be the radius of gyration. So k square is equal to what? K square is equal to this term fully. So we are writing that as k square, which is equal to this term. So in the square root in the பக்கம் வந்துச்சுனா we get it as root of. So this expression is the root mean square distance of all the particles. Okay, so radius of gyration is a root mean square distance of all the particles. Clear? And so I is equal to m into k square. Suppose when we have the moment of inertia for a rod of mass m and radius, length L, and that moment of inertia is given by I is equal to 1 by 12 m into L square. So this formula we have derived already for the moment of inertia, is it not? So that formula has been written here. I is equal to m into k square, and also I is equal to 1 by 12 ml square. Now m gets cancelled, so we get k square is equal to 1 by 12 into L square. Okay, and so k is equal to root of 12 into L. Okay, this can be written as 2 into root 3. Yes, and so this value we are writing it as k is equal to 0.289 of L. Okay, so this is the other form for this radius of gyration.